Okay. Okay, so we continue. Okay, so just before Maghrib, so now we stop at the thermal efficiency to evaluate the performance of any heat engine, cycle, machine, etc. Okay, and then next, okay. Okay, now only, okay. Just now, all of the introduction just now is about the first law of thermodynamics, which is the energy balance. Okay, the energy cannot be created or destroyed. Okay, so we use that concept, that principle law, to evaluate the performance of any engine model, machine that we want to design. Okay, evaluate. Okay, the next one, just a little bit introduction about the second law of thermodynamics, about the irreversibility just now. Okay, so on top of the first law, we use another property that we call entropy. Entropy is noted as S, small s or capital S, just like the enthalpy just now. Enthalpy H, small h or capital H. Here, entropy is used to characterize the second law of thermodynamics, the irreversibility. So the unit is kilojoule per kilogram per Kelvin. Okay, means that the difference between enthalpy and entropy is the Kelvin, the temperature here. Okay. So joule per kilogram. Entropy measure the level of molecular disorder of a substance increase as it melts or evaporates. Okay, so if we have the process evaporation or condensation, we the level of molecular disorder, which in other words is the irreversibility. Okay, if it's this is like the irreversibility, the disorder. Okay, macam huru hara tu. Entropy ni sebenarnya dia macam benda yang huru hara lah, orang kata. Measure the disorder tu, irreversibility of a substance, of a process. Okay, so the disorganized energy, in other words we call it disorganized energy. Okay, so this disorganized energy does not create much useful effect no matter how large it is. So that's why second law used to determine, to characterize the useful exact energy that really produced by the system. Okay, because we want to cut out the energy loss or the disorganized unuseful energy. Okay, something like that. Okay, so this is we don't call it entropy balance like the energy balance, but this is the equation. Okay, the persamaan equation for entropy, second law. So the same definition in and out. Okay, the difference of entropy generation, entropy inlet and outlet rate is equal to the change in entropy. Okay, the entropy generation here. So entropy inlet minus outlet equals to the entropy generation. So this total up is the change of the entropy of the whole system. For example, we have this system, this control volume. Okay, so there will be mass transfer, heat transfer in and out of the control volume. Okay, so the change of the entropy outlet and inlet plus the energy, the entropy generated. Entropy generation is always positive value, more than zero. Okay, there is always entropy generated, the disorder, there's always there. So this total of changing, okay, will equal to the change in entropy of the whole system. Okay, entropy generation outside system boundaries can be accounted for by writing an entropy balance. Okay. Okay, so so that's all for recap of the first law and second law of thermodynamics. That I think the I just picked the most important part of thermodynamics that maybe we are going to apply to use later on. Okay. So okay, so now okay, why renewable energy? Okay, so now we kind of start the introduction for the first chapter, but basically it's still introduction. Okay, so I just going to introduce first renewable energy, a bit about the statistic, the graphic. Okay. Okay, ni kecil sangat tak nampak. Okay, so okay, we skip this one. You later on when I share the slide, you can look at the besar. Tak apa. Slide tak apa, ini tak penting. Kita tengok graph je. Okay, okay. Okay, so this is the some of the latest, not really latest, until 2018 data about the worldwide energy consumption. So this is the source from the IEA. IEA is actually Institute no, Energy Agency, something like that. But it is in centralized in France, Paris, France. Okay, it's a worldwide international energy agency that come come up from with the policy, etc. Policy for carbon, low carbon, etc. Sebenarnya IEA ni yang akan keluarkan. Okay, so but IEA is based in Paris. Okay. So these are some of the data that they have. So first, the world total final consumption by source. Okay, if you can see here, I hope you can see. Look at it. So the most, if we look at from the 70s until now, 2015, 2020, most of the worldwide consumption source it comes from oil, right? You see, it comes from oil and electricity also. Okay, this one is others. Okay. Okay, so kebanyakannya majority is since 1970, a lot of the energy consumption we use oil. Okay, now and then, sorry. And then apa lagi? Okay, so I have some of the pie chart to focus more on this some of the source just now, coal, oil, and electricity. We look at the application. Okay, so for example here, the first one, coal. So coal is used a lot more in the production, manufacturing of the iron, steel, right? And non-metallic materials. Okay, so about 50% of the worldwide coal is being used to manufacture the iron and metallics and non-metallics minerals form. Okay, and then oil. Okay, oil of course is a lot used for transport, road, aviation, and non-energy use a bit. Okay, so basically on transport. So people for transport, we still depend a lot with oil. Okay, and then electricity. Okay, electricity, of course, industry and residential, our house, building, hotel, buildings, housing, right? We depend a lot on the electricity, of course. Okay, and the top 5 countries for the big countries, okay, negara besar ni yang paling banyak supply and consume energy. This is the supply. So basically China, of course, number 1, US, India, Russia, Japan. Okay, and top 5 also final consumption energy. Also China, US, India, Russia, and Japan. So mainly for China, their energy consumption focus on the industry. Okay, industry, and then for US is more on the transport. The transport. Actually US, saya pun tak nak sampai US, saya pernah Europe kan. Just to share lah. Basically macam sebab kalau kat Europe sebenarnya macam dia transport quite macam, yelah kita boleh macam tabik lah kan, quite advanced lah, macam dia punya train kan, France, Germany apa semua. Dan bila saya dengar ialah kawan-kawan yang belajar kat US sebenarnya kan, sebenarnya US ni dia dari sudut transport dia macam tak se-advance Europe lah kan. Sebab dia, kalau aeroplane je lah sebab negara dia besar kan. So dia memang banyak guna flight lah kan untuk travel within their country lah. But actually kalau ikut macam transport yang macam bus, train, Europe lagi macam kata lagi efficient lah sistem dia apa semua kan. So sebenarnya US ni dia banyak dia sama ada flight or macam road lah kan, road trip kan, orang banyak jalan raya biasa dia punya yang macam public transport dia like bus, train apa semua tu dia sebenarnya lebih yalah berbanding dengan Europe tu dia kurang sikit sebenarnya, dia tak berapa advance sangat lah. So dia masih depends on the macam kind of traditional lah road apa semua kan. Punya transport. Kalau India kalau train apa semua kan. So sebenarnya US ni tak adalah semua benda pun dia expert lah kan. Sebab ada part yang I think Euro or Japan lagi advance lah. China industri. Okay. This is just 2018 World Electricity Generation. So macam kurang macam tadi lah. Part most of it comes from coal, gas, masih coal, gas, hydro. Malaysia sebenarnya kalau renewable energy most of it yang paling banyak guna kalau renewable energy hydro lah. Sebab kita ada banyak sumber water kan. Nanti kita tengok yang Malaysia. Okay, this is Malaysia. Okay, now we focus just to give a little bit data on Malaysia lah, our country of course. Okay, this is from our World in Data. Sekarang ni website ni famous lah kan, nak tengok data COVID kan. Okay, so actually our World in Data dia bukan ada data COVID je, dia ada semua data je sebenarnya. Okay, so Malaysia, where are we? Okay, so Malaysia energy consumption by source from 1960s, 65 until 2019 current lah kan juga 2020, 2019. So kita masih energy consumption kita masih rely a lot on oil and gas lah. Malaysia kan. Coal jugalah. So renewable energy we dah banyaklah polisi kan, government policy and start banyak research on the renewable energy, but we still at the macam beginner lah kan. So there's some renewable energy that most used most macam developed currently in Malaysia, like I mentioned just now, hydropower and solar. Macam wind apa semua tu ada juga, tapi sebab because yalah, one thing climate lah, depends a lot on the climate kan. Solar of course because we have that potential, even though the constraint for solar is the of course the budget lah kan, dia pun kata cost dia, costing ni kan. But we have that source, that hot and sunny climate tu kan. But for example, if wind energy susah sikit, it's a bit difficult, bukan tak boleh, okay, tapi untuk macam contoh Malaysia susah sikit lah sebab kita punya wind speed tak not very high lah, tak ingat berapa, tapi tak tinggi sangat kan. Kita kalau nak banding lagi, walaupun macam kita rasa macam kalau bila ribut guruh tu rasa macam angin dah kuat dah, tapi cuba kalau yelah, if you have chance to travel to some of the country, Japan especially, even masa kat Europe pun memang kalau kuat angin tu memang kuat betul lah. Nak jalan depan tu memang tak boleh lah. Kalau macam sekarang ni right now is autumn kan. Kalau kat Europe tu ataupun kat northern area lah kan, memang kalau kata macam ribut tu memang kuat lah, kita tak boleh nak, angin dia memang betul-betul kuat lah. So Malaysia tak sampai situ lah kan, tu tak perlu kena tsunami ke apa lagi kan, tak pernah experience lah. Susah juga lah kalau kita nak Malaysia untuk advance kalau dalam ni lah. Even ocean pun, ocean thermal energy kan, sebab kita sebab dia perlukan of course and space yang banyak lah, luas. So banyak so Malaysia banyak kalau renewable, in terms of renewable energy, that yang we have started on hydropower and a bit on the solar. Okay, lepas tu this one is share of energy consumption by source. Lebih kurang sama. Okay, so we have this one on the right hand side is the in terms of percentage. So our oil and gas kan, oil and gas still a dominant, the majority consumption, but oil start to decrease. Okay, they start to less depends on oil, and so there is we start to develop familiarize with the renewable energy, so hydropower, solar, nuclear, wind. Okay. Okay, lagi Malaysia lagi share of primary energy from fossil fuel. So from fossil fuel oil semua tu still dominant, more than 80%. And then share of primary energy. Okay, so I just pick some of the renewable energy that been used, been developed worldwide. Okay, not just Malaysia. So kalau solar, Malaysia, kalau boleh nampak, Malaysia, we are at in like in the middle, orange kan, about 0.1% to 0.1%. Tak tulis tak dapat. Okay, kawan ni lah. Okay. 0.1% to 0.3% lah, lebih kurang kan, Malaysia the apa tu share of energy from solar. But the highest country that started to use depends on the solar energy, lebih kurang 3 ke 10% ni apa ni, Germany, Italy. So that's why, like I mentioned just at the beginning, we have this project, this grant for Erasmus. The leader of this project is from Italy. So dia orang memang dah start develop banyak lah untuk solar. Then of course Japan pun solar kan. And other country, US about 1% to 3%, Australia kan. So Malaysia macam tengah-tengah lah, at least berbanding Indonesia. We explore more lah kan, higher lah solar energy. Okay. This is a share of primary energy from low carbon source for Malaysia. So of course, one of the reason why we need to invest, or why we need to start to focus or look into the other types of source of energy, renewable energies, notably, is that because we want to reduce the carbon, okay, to lower the carbon emission, okay, carbon dioxide emission. And then year-to-year change in primary energy consumption by source, Malaysia. Okay. So we still we are in a developed country, so we still depend a lot on gas and oil, but we start to reduce the use of coal and start to look into hydropower and solar. Wind, tengok ni, wind, nuclear masih very very small lah, kosong kan, belum nampak lagi potensi tu, tapi boleh cuba, tak tahu. Okay. Okay, and then okay, so these are the I think this is the consequences of why, like I said just now, why we need to explore other types of energy, because one thing, we want to reduce the undesirable emissions, reduce the greenhouse gas effect, which contributes to, of course, global warming, right? All this gas, nitrogen oxide, hydrocarbons, particulate matter, right? Okay, so this problem can be tackled by two methods using, this one is important, using renewable energy source to replace fossil fuels, or another method is implementing energy efficiency practice in all aspects of energy production, distribution and consumption, so that less fuel is used but with the same output. Ni yang berkait dengan design kan. Means there are two methods to tackle, to overcome the problem of the global warming, this etc. So actually another one is recycle, reduce, reuse tu. 3R, 5R kan. 3R, 5R, reduce, reuse, recycle. Saya ada 3 lah. Three methods that usually kalau apa industri dia promote 3 ni lah. Dan one of the thing yang that I heard lah from apa tu green tech company, one of the agency energy agency government agency kan, the apa tu the engineer dia share lah. So ada 3 method kan, there are these 3 methods to tackle this global warming problems. So Malaysia kita sebenarnya banyak lagi fokus, we still try apa tu to focus more on the energy efficiency practice ni. Kita dah start macam research on the renewable energy source apa semua kan, wind, solar betul. But our focus macam lebih banyak more focus on the energy implementing energy efficiency practice. Ini maksudnya macam to educate the society, masyarakat society how to use electricity more efficient. Kita cuba concentrate yang tu dulu untuk educate masyarakat dulu. Sebab that one part pun, this one pun dah boleh can reduce a lot of the energy production, energy consumption semua kan. So and the reduce, reuse, recycle semua tu lah. Sebab kita masih ialah salah satunya budget jugalah kan. Renewable energy source ni memang dia very costly lah, mana-mana source pun. Dan but so the research is still in development, develop. So tu apa yang one of the initiative from the government and agency semua, kita try to educate masyarakat on the energy efficiency practice. So tak semestinya kita perlu create renewable energy je hanya untuk save global warming. So these are some of the policy lah yang kita boleh buat. Okay. So what is energy efficiency? So when we mention energy efficiency, is that our aim is to reduce energy use to the minimum level as possible, optimize the use of energy without reducing the standard of living, production quality and profitability, of course. Okay, like I mentioned just now, for aircraft engine, of course we want an engine that is more performant, higher efficiency, can perform better, etc. But at the same time, we also focus on the how much the thrust power, the power output that can the engine create, the engine produce. That is more important. So we have to compromise between these factors, kan? Okay. So energy efficiency doesn't mean higher efficiency, not only that. Okay, so we have to look into different factors: costing, budget, economy, society impact. Okay, and then expression of the most effective use of energy resource resulting in energy conservation. Most effective use, right? Just now, energy efficiency to use wisely, more efficiently, can only reduce fossil fuel use, while renewable energy can directly replace it. So we turn into our focus to reduce fossil fuel. So we turn our focus to methods, renewable energy source. Okay. Yang ni dah ke? This is also about carbon. So like carbon intensity. So Malaysia kita still banyak lah, 0.2 kilogram per kilowatt. Okay. So, slide saya ni. Oh, ada 3 je lagi slide. Okay. So, renewable energy source. So, these are, like I mentioned, I already mentioned some of them. Okay, this some of the renewable energy source that are available. Of course, means renewable energy source means that I use short form RE. Okay, so RE can be renewed and sustained. We don't want energy that just can be renewed but cannot sustain. So this sustainable, that we always talk about sustainable development goal kan, SDG. Right now kan, semua orang pun pakai SDG kan, sustainability. We talk about sustainability. So we also want to design technology not only renewable but also can sustain. Sustainable sustainable in terms of cost, sustainable in terms of production, right? Sustainable in terms of manpower, semualah, okay? Without any depletion and any significant effect on the environment of environment impact, sustainable. So, okay, so types of renewable energy source: solar, wind, hydro, right, water, biomass, waste, biomass, from, for example, wood pellets, but from the waste, municipal solid waste, right? We produce power from the waste, solid waste, waste energy, waste heat, geothermal also, okay? And then there are also this one, the ocean, from the ocean. Ocean also is one type of renewable energy source. Is just that currently it's not really economical compared to the others, and it's still in the experimental and development stage. Actually kalau because several months ago, July, I did join one conference, Malaysia lah, locally, organised by the Green Tech agency government dengan USM. They talk about tentang development solar di tengah-tengah ocean lah. They combine the solar with the ocean energy ni. Adalah possibility dengan development, but still in the current experimental stage lah. So actually there are three types of ocean source, ocean energy source ni. Number one is ocean thermal energy conversion, which is we call it OTEC, OTEC. This source use the ocean thermal gradient between cooler deep and warmer shallow or surface sea waters to run a heat engine and produce useful work. So ocean thermal, the mechanism behind the mechanism of the ocean thermal energy is that it use the thermal gradient different of temperature of the at the bottom, at the top and bottom lower level deep of the water, because the water at sea level upper is more cooler, means low temperature rather than the one deep down in the sea. So due to this thermal gradient, the change of temperature, the difference temperature, so it can create it can produce thermal power to run engine. So that's where it can form electricity power. So bila dia ada change, dia ada different level of temperature. So recall back the cycle just now, cycle tadi yang boiler, heat source, heat sink tu. So that's why once ada difference of temperature, kan, ada difference of temperature, bila ada je different temperature means ada heat exchange. Sama ada heat exchange tu kuat ke tak tu, itu depends on the level of the different thermal gradient tu lah. So once bila ada je a different level of temperature, sebenarnya dia dah boleh hasilkan something, power. Kan? So actually the smaller kalau kita kalau kita perlu, kalau smaller thermal gradient but boleh hasilkan banyak output, itu lagi better lah. Sebab biasanya kalau nak hasilkan banyak output tu, gradient temperature tu kena besar. Tapi itu yang kita kena study tu, design, analyze sistem mana yang minimize thermal gradient tapi still boleh hasilkan output yang banyak. Okay, so starting point dia adalah thermal gradient tu, difference of temperature tu. Kat situ lah dia trigger heat transfer tu. Once it triggers heat transfer, so we have thermal energy. So once we have thermal energy, dia boleh converted ke another form of energy, mechanical electricity. So itulah yang tadi tu kenapa penting kita ingat balik first law tu. Dia one form to another form. Once we have kita jumpa satu form of energy tu, kita boleh convert dia and produce work, electricity, etc. Okay, so dia punya prinsipal dia macam tu je, transform energy. Okay, and then wave, solar energy from the sun creates temperature differential that result in wind. Ini kalau wave ombak dekat ocean tu pun boleh, can create energy, but depends on the sun, solar energy, and also angin lah, kan. The interaction between wind and the surface of water create waves. So bila ada ombak tu, which are larger when there is a greater distance for them to build up. So sama juga dia punya distance, dia punya gradient dia tu yang trigger how much the energy that can be produced. And then tidal, yang ni the energy from moving mass of water. Okay, the water kat bawah ni. Okay, water, air tu bergerak kan, move. So from there, the movement of the water, kan, movement of the water tu, bila movement means ada kinetic energy lah, selain pada thermal energy. Okay, so the movement of the water can create heat source, okay, hydroelectric power macam tu. So sama je dia punya konsep, from one form of energy transform to another form of energy, except that the constraint, the cons of the kelemahan lah, tidal energy ni, dia punya turbine blade ni kan, sebab dia ada pakai turbine ni kan untuk transform, convert the energy. It can strike and entangling organism, semua hidupan kat laut ni lah. Okay. Fossil fuel ni tak perlu kot. This is the nuclear energy. Nuclear energy Malaysia ada. We have agency nuclear kan, yang government punya ada, tapi belum widely. I mean dekat Malaysia, in Malaysia belum widely used lagi lah. But nuclear energy, especially France lah. Kan saya tahu dulu kan kat France memang banyak lah. Apa tu? Dia punya kilang dia tu. Nuclear energy France antara leading country lah. Okay, I think habis dah slide saya. Okay, so there are some of the introduction about the current situation in Malaysia and worldwide, a bit about the renewable energy. Okay, any questions, anything want to ask? Okay, data-data ni tak kena hafal lah kan, dia just information kan, insyaAllah. Okay, actually, so today sebenarnya saya dah nak bagi dah first assignment yang simple je. Okay, sekejap saya tak download kat sini. I look at my slide ni. Okay, but I think I have to share from this device. Kena tukar kejap. Yang ni. Stop yang ni. Okay, saya share from here pula. Mana tadi share screen? Oh ni. Ni, this one. Okay. Okay. Okay, so first assignment, tak apa, tak susah pun. Okay, first assignment, what I want you to do, ialah kita nak sama-sama sharing and belajar to learn and share kan. Sebab kalau saya seorang je cakap boring lah kan. So kita we'll do one simple assignment. I want to ask each one, kita ada 4 orang je, only 4 of you. So maybe each one of you pick one of the renewable energy source just now, wind, solar, if possible better lain-lain lah kan, so that we can share different data, different source kan. We explore kan. Kalau sama macam boleh je, tapi macam tak best lah kan. Okay, so maybe so okay, first I explain. Okay, so I want to ask each of you to explore each of the renewable energy technologies. Okay, so what you have to do some background study, read a bit, a literature review about the technology. how the system works, right? What are the types of the system exist. For example, solar energy, we have solar photovoltaic, we also have solar thermal, right? So there are different types of solar energy. So just try to look at it, try to look at them, search about it, search about these different types. Even wind energy also, we have different types of wind turbine. Try to look at that, and what are their function, just very simple function difference, okay? And what are their challenge issues, pro and cons of this technology, solar energy, wind energy, geothermal or biomass, bioenergy, pro and cons of the technology. So sama lah, challenge, issue, pro and cons of the technology, and impact on the economy, environment, right? Okay. So I would like you to kind of write a report around maximum 5 pages, so not too long, not very long. Okay, and do like a present in 3 weeks, 12. Okay, so I have to change this in Wednesday, right? We change the Wednesday, so Wednesday will be 10 lah, right? 10 November lah, kan? Kalau Wednesday, kalau if we change our class to Wednesday, it will be 10 November. 10 November week 4. So in 3 weeks, ada lagi 3 minggu lebih kurang. Okay. So you present 10 minutes or 15 minutes pun okay. Relax ya, sharing je. In poster or poster ataupun nak buat slides pun boleh. So one report and another one is for presentation, poster, or you want to do a slide PowerPoint also can. So in the present, just share your apa yang dapat lah, your output from literature review. Okay, if possible, if you can also present the schematic diagram, means that the process, the system just now, how the cycle, all right? If there's solar energy, it must have the cycle from the heat source to the power output. So if possible, include the system diagrams and explain how the system works. Okay, and deadline. Okay, 10 means that the presentation is on 10. So you present and then you submit the report. Method also, so I will assess you, and just this accounted for the 10% of the marks, okay, in the presentation and report. Okay, so okay, can we do that? So in 3 weeks, so we have about 3 weeks to prepare, insyaAllah. Bukan minggu depan lagi lah. Minggu depan saya buat lagi. Okay. Okay, nanti saya I will share this the slide, ada 3 slide lah tadi, introduction, chapter 1 tadi, and the assignment, insyaAllah. Okay, kalau ada soalan, any questions? Okay, kalau tak ada, sampai sini je lah. Okay, untuk minggu ni, for this week. Okay. Okay, I stop sharing, stop recording.